So probably a couple people kind of looks like have been kind of coming in here a little bit late. Those of you that brave the elements, I'm glad to see you guys here. Hopefully we get a couple more people in here when the weather's a little bit nicer. But this will work. We kind of have it already set up for everything on Zoom. So we'll kind of dive into some new material today and kind of go forward as we typically do. One thing I want to mention before we do get going, I had that, and I think I mentioned that homework assignment, kind of you could turn a hard copy in today. And so I had the due date set for the beginning of class. I had a couple people email me, and I'm not overly concerned, and I'm honestly not going to be able to get around to grading it tonight. So I'm going to extend that due date. If you want to, you can upload that homework to Canvas at any point today. So when I get back to my office, I'll change the due date to be the end of the day today. Okay, so you got a couple more hours if you were kind of time crunch. But if you guys have it, just shut up, you want to turn it in. If you brought a hard copy, that's still fine. So let's jump into things here. So we left off in kind of the additional video I put up. We were talking about all these different pricing strategies that monopolists had, right? So basically, how could they convert as much consumer surplus into producer surplus as possible, right? So kind of running along this idea with some issues we're going to run into with monopolies is that idea of a natural monopoly. Okay? So, the easiest way to think about these is it's really a market in which there's only enough demand given the costs, right, to support one company or one firm. Right? So here we're thinking about maybe for certain sports, there's only enough demand really for there to be one league, right? Or within an area, kind of one team, right? Different levels of monopoly there. So if another kind of firm here, another team or another league were to enter, there isn't enough demand for there to be two leagues or two teams to earn profits in that area. So typically this happens when we have really low marginal costs, but really, really, really high fixed costs, right? That's why we see things, cable companies or these different companies where the infrastructure just to lay down like the cable lines is so high that originally there may only be one company in a certain area that is able to profit in that market. So, one thing that's nice, typically we think about monopolies as being a bad thing. However, in kind of the sports world, if we think about, it's going to give us some stability, right? Kind of in our fan base, not having to compete with another team or another league. And, a lot of people would argue that if, we could kind of make this model pretty complicated where there's externalities and people don't realize what the actual benefits are to them, that potentially keeping quantity low with a monopoly is actually beneficial for these leagues and these teams, but also beneficial for the consumer because it keeps the quality high, right? If we get too many teams, right, or too many leagues out there, they start to kind of get a diminished quality of product. Okay? So the way that we understand these natural monopolies, let's see here, hopefully we can switch a little bit quicker today. Oh, did I not click on it? Or is it just taking? Oh, that would help. So we think about these natural monopolies, right? Let's see this. Yeah, it's not too bad. So we just think about, we could have quantity down here, we got price up here. If we really wanted to, we could kind of change this into wins, right? Thinking about not kind of the simplified kind of win structures or win markets we were thinking about, where I had this constant kind of marginal cost that was just a straight line. It just made things a little bit easier. It's likely what's more likely to be the case is, let's say I've got some demand curve here that they face. They're monopolists, so they've got this twice as steep marginal revenue that they'll make decisions based off of. And then, maybe my marginal costs are relatively low. So maybe my marginal costs look something like this. Okay. As a result of really high fixed costs though, right, we might end up with, here I want to make sure I get this to look good. So let's do, maybe my long run average cost, or an easier way to think about this is maybe average total costs. Okay. So the monopolist is going to choose a point where marginal cost is equal to marginal revenue. So that's right here. Okay. go down here, we can think about this is the point where the monopolist would be. Now they then go up to that demand curve, kind of choose their price. Oops, if I can write, we'll call this kind of the price of the monopolist. So notice, price is slightly above our average total cost here, right? So if we go back to these cost structures, talking about kind of how we could rewrite profit here, we think about this as this is going to be I don't know, total revenue minus total costs, right? If we just kind of think about the difference between these two, and we want to think about average total revenues minus average total costs, right? This average total revenue is based off of kind of the price, so we could pull out a Q from this, and there'd be a P here, and then kind of with our total costs, we can think about kind of quantity. Well, how do I want to denote this? Average total revenue would be total revenue, which is, am I running off? No, I'm not running off the screen. Price times quantity over quantity, and then average total costs would be something like total cost, oops, over quantity. So we're looking at this point where is the price kind of above average total cost? If that's the case, we're going to end up with positive profits, right? So, this is good in the sense that you can kind of think about there's some profits here being earned by the monopolist, right? However, if there wasn't a monopolist in this market, the point at which we'd arrive in the long run is kind of where this demand curve hits the marginal cost curve, right? If we had a perfectly competitive market and there was no marginal revenue here. Well, the issue is at that point, right, you could call that maybe the quantity at which a perfectly competitive market arrives at. At this point, whatever the price is, okay, price is below average total cost there. And so now the firm's going to be experiencing negative profits, right? So the average kind of revenue they're bringing in with that price, right, is below kind of what their average costs are. Right? So this is an example where if we didn't have monopoly power, right, that marginal revenue curve is gone, we arrive at a point in a perfectly competitive market where a firm wants to leave. And let's say, all we needed to have a perfectly competitive market here was one other firm. Well, now both firms are going to be experiencing kind of negative profits. One of them leaves, we're back to just a monopolist, right? So this is the idea of a natural monopoly. Given the cost structure and given where current demand is at, there's only enough demand for one firm to profit. Now, if demand gets higher, right, you can imagine if demand shifts way up here, well, now we can kind of think about wherever demand intersects marginal cost, it's probably above average total cost, and now we have positive profits. So if demand gets high enough, potentially this natural monopoly could fail to exist. But given the current cost structure and demand, this is how we're thinking about natural monopolies. So let's go back here. So we're thinking about, how do we end up with these natural monopolies? What's the actual market they're monopolizing? It's not as simple as it might originally seem. So monopolies, in order to have a monopoly in a market, there has to be no other substitutes, right? Because if there were substitute goods, people are just going to stop buying my good and kind of purchasing this other good if I increase the price too much as a monopolist. But if we think about, well, what's the market for Green Bay Packers games in the city of Green Bay, right? Well, if we're just thinking in general, right, is it the market for sports? Because in Green Bay, you can imagine there's people who can travel, they live in Wisconsin. There's NCAA basketball games, there's NBA games, right? They're probably near enough to where you could think about the Brewers, right? So we wouldn't say that the Green Bay Packers are necessarily, which if you're not familiar, this is an NFL team, right? They're not necessarily a monopolist when it comes to the market for sports, right? Because there are some substitutes here. If all I care about is attending a sporting event, doesn't matter which one, then no, we wouldn't have a monopoly in that market. But what about for football games? Well, there's games that are on TV. People can, even if it's in-person games, we can still think about there's college football going on. Potentially I could drive to other nearby cities if I don't live directly in Green Bay, maybe I could drive to Chicago to see a game. And then if we think about, well, what about the market for in-person Green Bay Packer games? Well, yeah, that they would have them, be a monopolist, right? So it really starts to become important that we think about what market and define the market that we're looking for, because yeah, they wouldn't have a monopoly in the sports market, but for Green Bay Packers games, right? People wanting to attend in-person Green Bay Packers games, they would have the monopoly. So we'll be careful a little bit about how we define the markets that we're looking at. So one thing that can create monopolies in different markets is barriers to entry. So that's one of the major things we talk about. Typically, this is going to be something that is set by the government, some type of or collusion from firms that set these barriers to entry. And so here, leagues actually try to maintain that monopoly status. If we think about why, well, let me see if I can pull this up here. I think I still have it here. Yep. Right? If we were thinking about what we had drawn earlier, and this is a natural monopoly, but it applies either way, right? The price the monopolist charges is much higher than the perfectly competitive market, right? So they're able to kind of increase profits more. Well, the league likes that. The league wants to maintain that monopoly status. And so they set up some barriers to entry so that teams can keep their monopoly power within their own market. So we talked about this a little last class, I believe, where if you move into a city where there's an existing team, every league has their own price tag of what that will cost you. Now, this is an older one, right? I didn't kind of adjust these for inflation. But if you go back to when the Clippers moved to LA, they had to pay a price. Leagues have realized, as the market for sports has grown, they're willing to pay much more to maintain that monopoly power. And so, the most recent kind of move of the LA teams in the NFL, the Chargers and the Rams, they paid a huge amount to the league. Because the league's like, look, if you're going to be competing with each other, right, in the same market, you're going to cost the league money. So in order for us to kind of, we need to be compensated for those costs, right? So you're going to have to pay us a certain amount in order to both move to that same location. Okay, and that's just, to me, that's wild that the Chargers and Rams could justify, yeah, that's okay. It's LA still, even sharing LA is much more attractive than moving to some of these other cities. And I doubt they made that. I'm saying this somewhat facetious. It's not like they made that decision on a whim, right? There was a lot of research that went into that. So another thing that doesn't make a lot of sense is if I'm a competing league, right? Now we're not thinking about teams competing with each other, but leagues competing with each other, like the AFL, which was kind of an additional football league. Right? They didn't try to target locations that already had teams there. So at the time, the original AFL, there weren't teams that were actually in Minnesota. Or potentially, if we thought a large enough city like Dallas, maybe we try to move to a large city, because even splitting demand there with another league, I'm still going to be doing better than if I could monopolize a smaller city's location. Right? Another one that we see, if I am, barriers to entry that can create. What's a huge barrier to entry? Sometimes it can just be large fixed cost. I mentioned this with the idea of why there's only one cable company. Right? Well, what's one way I can make sure that other teams, if they don't have the resources to kind of build their own stadium, I can deny them use to mine. So AT&T Stadium in Dallas, right? They use this for concerts and monster truck rallies, right? Anything they can when they're not using it to play NFL football games. However, if an AFL team comes along and says, look, we think we're going to put a team in Dallas, right? Can we use your facility? Well, if the league thinks at all that league, the AFL, is going to compete with the NFL, the NFL is going to say, well, no, you can't. We're not going to let, it doesn't matter how much money. We're not going to let you, well, I shouldn't say how much money, but not for kind of the typical cost will I let you use our stadium, because you competing with us is going to eat into our monopoly profits, right? So teams and leagues will try to create barriers to entry as well to competing leagues, right? TV deals, is one thing in which, I get, if you're signing a new contract with a broadcast company, I suppose there's probably, I'm not a lawyer. I'm guessing there are ways to build into the contract that you're only going to make a deal with that company if they don't make a deal with possibly other competing products, right? Or other competing leagues. However, if you don't have that and you've already got the deal signed, well, there, I might be looking as a competing league to really make most of my money, not in ticket revenue, right? And this is actually what we see. Like if you look at leagues like the AFL or XFL or these other leagues that try to compete with kind of one of these top 4 professional sports leagues, they know that their ticket revenue is going to be relatively low, but they bank on in the off season, potentially if we can create our league in the off season of these other major sports, there's a lot of kind of airtime on TV that's open, right? And that these companies, these broadcast companies would like to have some type of a sporting event on. And so maybe these TV deals are a way in which these leagues can actually compete with kind of our top 4 kind of big professional leagues that we're thinking about, right? Being the NFL, NBA, MLB, and NHL. Okay? So if we go back kind of the 60s, the AFL actually, they had some big broadcast deals that actually allowed them to be a valid competitor to the NFL, right? However, if we see bad TV ratings, it can also doom some leagues. We've seen kind of recent evidence with the XFL not being able to really earn that high broadcast revenue, not do very well, good numbers, which kind of then leads to these broadcast companies not wanting to make deals with them, and it is really, really kind of kills those leagues, right? Because they're not banking on ticket revenue; they're really banking on their broadcast revenue, right? We are talking about those different sources of revenue. Okay. So all this kind of is a general discussion. All related to monopoly power, but there's additional type of power these leagues have that also benefits them. So we'll do a little bit of history here, but I'll kind of show you some models of this as well. So, if we go back in time, sports have been kind of a weird exception to the rule. So, the Sherman Act was this kind of push for really trying to break up monopolies. I'm bad at history. I forget the exact years. Do I have it here? No, I don't. I'd have to go back. I want to say it's like 30s, but that might be wrong. But it basically laid out all these rules where, we don't like to see companies collude with each other to prevent competition because we know the lack of competition will drive prices up and hurt consumers. So this is really a way to protect consumers. And really, like I said, you could go through, there's the actual specifics of this act, but the general idea was to prevent monopoly power, prevent collusion, and kind of increase the competition that we see in every market. Now, we do have some exceptions, right? If there's a natural monopoly, we can't go in and break up that company because, well, if you get rid of that company, you can never have enough demand, or at least at that current time, to support 2. So there are exceptions that can be made, and if you can prove that your fixed costs are so high that you're a natural monopoly, the Sherman Act really doesn't necessarily apply to you. So sports teams, right? If we think about them, if we think about the teams, they're owned individually, they're coordinating their actions through the league, right? So they are colluding to a degree, and they are making decisions that are attempting to keep out other leagues, right? We talked about a couple of them. Some of those barriers to entry, right? They establish rules, which doesn't really maybe seem like it's that great of colluding behavior, but they definitely arrange their schedules. They make kind of broadcast deals through the league, so they're coordinating their efforts. They're definitely some type of collusion behavior, right? They set things like league minimum salaries, which would mean that if new teams wanted to enter the league, that it's increasing the cost. So if you increase costs, you make it harder for a non-existing team to then enter the league. So why don't they seem to apply the Sherman Act to a lot of these sports leagues, right? So we go back through history a little bit. Baseball was kind of the first one that there was cases brought to the Supreme Court. So let's see. I'm going to get a little bit of a history lesson. I always kind of forget some of this, but in 1901, the American League began to compete with the National League. So I talked about this a little bit. The National League guessed wrong on what the marginal revenue of the kind of increasing population cities were. They thought that the optimal number of teams for their league was, I think it was 8 at the time. And the American League said, well, you guys are wrong. We've got better data to show that there's another 8 cities out there that have enough demand to make it profitable to have a team there. They started a competing league, and neither of them really had monopoly power in the sense that they were competing with each other. So In 1914 to 15, there was actually a third league called the Federal League, right? So they tried to get up and going. And by the time we get to this point, the American League and the National League have joined together. Why did they do that? Well, because they realized competing against each other makes no sense if we can just merge and become a monopoly. All of our teams can enjoy an increase in surplus, right? With this additional monopoly power that we now have. We're no longer competing with each other. So the MLB started denying this third league that thought maybe they could compete with the kind of big boys, so to speak. And, the Federal League said, well, look, they're barring us from even negotiating with their free agents. They're trying to prevent us from getting high quality players to provide a product where we know we could earn a profit if we were able to do so. So they brought this to the Northern Illinois District Court. There's a guy there at the time named Kennesaw Mountain Landis. I don't think I have any relation to him, but a close spelling there. And he was kind of known as this judge who was really breaking up a lot of these monopolies at the time, really adhering to that Sherman Act. But he's a really big baseball fan and kind of just dragged his feet. Right? So for over a year, he had this case sitting on his desk and didn't do anything with it. I'm not conspiracy minded here, but it's also interesting that he ended up later becoming, after kind of the ruling on this case, to be the MLB's first ever commissioner. He kind of never ruled on this case kind of a lot, over a year. What does this do to the Federal League? Well, they essentially aren't able to earn profits. They eventually just kind of go away. Right? So he doesn't even have to make a ruling on it. By simply dragging his feet, he knows that's going to kill this league that wants to compete with the MLB. 1922, it ends up kind of getting up to the Supreme Court, and they say that baseball is not subject to these antitrust laws, right? So they eventually get this ruling like years later, right? And they say they're not, they are completely exempt to these laws. And so, the MLB likes this, right? Because now they can kind of continue to operate as a monopoly, and the Supreme Court is saying that's okay. However, they said it shouldn't be used as precedent, but this is somewhat semantics. Once I make a ruling, everyone's going to use that as precedent. So the Supreme Court said that it should not be, but what we see play out throughout the rest of the next, almost 100 years now, is that it really has become a precedent. Okay? So what did this do, right? If the MLB was able to prevent other kind of new competing leagues from getting access to their players, essentially what they were becoming was, for the existing labor, or for the labor that existed out there in the market, right, these Major League Baseball talent level players, right, it made it so that there was really only one employer, right? If Major League Baseball can prevent you, once you're in there, from signing with every other team, or every other league, I should say, sorry, then essentially they now have not monopoly power, but what we call monopsony power. So monopsony power is when there's not one producer of a good, but when there's only one consumer of a good. Okay? So this is a little bit weird, because when there's only one consumer of a good, well, if we apply this to the labor market, right, who is consuming labor? Those would be the leagues, right, or the teams. Right? Thinking about the league kind of coordinating the action of the teams. So I've got some of the kind of byproducts. I'm going to show you a graph here in just a second, and we can determine, or we can arrive at the fact that once we see monopsony power in a labor market, that leads to lower wages, right, or lower price being paid for labor, and a smaller number of workers, or a lower quantity, right, of workers. So let's see. I want to go to stop share. There we go. So what's that going to look like if we're trying to draw kind of a graph to reflect this? I'm going to switch to blue because I think my black marker is down a little bit. I've got some new ones that I'm supposed to get in here this week. So let's think about, we're looking at the labor market. So we'll call this quantity of labor. We had a little bit of discussion. We can think about this as the number of players, the hours one player is putting in. But for the sake of this discussion, we'll kind of think about this as the general market for all players. So the quantity of labor here, I'll probably reference as the number of players. Okay? We then have the wages or salaries that or the contracts that they're signing. And so we think about, we've got the supply of labor, we've got the demand curve for labor. Now with a monopoly power, that was where we had one producer, right? And because we had one producer, they were making their decision based off this demand curve. But because they were trying to choose a single price, right, these single price monopolists, they were facing a twice as steep marginal revenue curve through which they were then going to make their optimal quantity choice. It's the exact opposite when there's only one consumer, right? The one consumer says, well, look, I know these are the marginal costs, right, that the firms are currently facing, right? And so they'd be willing to supply this many units of labor, or there's this many people kind of willing to work, right, for whatever that given wage is, right? Whatever point we're at on the supply curve going over that given wage. So what they're going to do is be able to set kind of a single wage. And here I'll explain, this seems a little bit goofy in the context of sport, but if you think about it, we could be setting like a constant wage per unit of talent, right? So if we don't want to think about, there's obviously variation in the quality of players, but if different players have a higher number of units of talent, we're still going to end up paying that same wage per unit of talent, right? It's just that they have 20 units instead of 10, right? So this is the general idea that we're going to try to set a single wage per unit of talent, okay? So what does that result in? Well, now, right, if I think about the demand curve reflects the marginal benefit, and we've been kind of try to hammer this home, to the teams who are hiring this labor. They're going to set that equal to the marginal expenditure curve of what it's going to take them if they set that single price for that unit, or that single wage for each unit of labor. So they will choose the point where the demand curve, or their marginal benefit, is equal to their marginal expenditure. Right? It's a little bit different than the monopoly markets we were thinking about, because there we had a twice as steep marginal revenue curve. Here, if we keep supply and demand linear, we've got this twice as steep marginal expenditure curve. Okay? So they'll choose the optimal quantity where that marginal benefit is equal to the marginal expenditure, or the demand curve hits that marginal expenditure curve. Right? At that point, they know that the labor is willing to work for this wage, right, per unit of talent. Okay? So they'll choose the quantity, the optimal quantity, down here, right? And we'll call this M for monopsonist. But then, similar to a monopolist, we'll choose the quantity and then go up to the demand curve. Well, now they'll choose the quantity, but go down to that supply curve and say, I know people are willing to play or provide their labor for this wage, whatever that wage point would be at on the supply curve at that quantity. Okay. Let me make sure I don't have anything in the, I've been kind of ignoring the chat here. So yeah, my sound okay to you guys, or is there any questions before I keep moving here? Could you sound good? Slide the paper. You got to ask that question again. Okay. All right. So we've got this monopsony kind of model that we're going to go off of. And what we've seen here is, well, where would the perfectly competitive points be? Well, that would be if we just didn't have monopsony power. We'd arrive at where supply is equal to demand. So here's our quantity for the perfectly competitive market. Here's the wage that we would see in that perfectly competitive market. So notice, with a monopsonist, quantity is lowered, and then kind of the price is also lower. Right? So with a monopoly, it was that the quantity was lower and the price was higher, kind of the exact opposite here. And why? Well, because for a monopolist, being able to charge a higher price for their product was a good thing. Here for the monopsonist, being able to pay a lower price for their labor is a good thing. Right? Having that monopsony power allows them to lower their costs. I'm going to try something here. This might be pushing it, but let's think about surplus for a second. Okay? So here, the consumers of labor, right? How much do they benefit for each unit of labor they hire? Well, however much that unit of labor benefits them, the difference between that and how much they're paying for it, which is now this equilibrium wage the monopsonist set. So essentially, this area here becomes consumer surplus. Well, it gets a little weird because here consumer surplus is actually the leagues, right? They're the ones consuming labor. So they've been able to kind of prior, what they would have had was this perfectly competitive wage. It would have sold out to here. So they would have had kind of this triangle as consumer surplus. What they lose out on here, they gain more, kind of gaining this surplus here. And so kind of they're better off, right? The consumers here, the leagues are better off. But where is producer surplus? Well, the producers are the people supplying the labor, the players. Well, here's the per unit wage they get. That's how much they benefit, right? The players, they benefit for how much they're being paid. And then how much does it cost them to supply that labor? The difference between those two. And so we'd end up down here with producer surplus, right? Which is quite a bit smaller than if it was a perfectly competitive market. Then the difference between the marginal cost curve and wage would be this entire triangle down there, right? So we've got our producer and consumer surplus, and then we can think about what does this area here represent? What would this area represent? Yeah, right? I'm no longer hiring these units of labor, so this is the surplus I lost out on or my deadweight loss. Okay? So it's a little bit different than a market where we're looking at the product and thinking about a monopoly. It kind of works, everything's almost like in reverse. Right? Any questions on that before I move on? Okay with that? Okay. So let's go back. All right. So we see a lower price being paid and a lower quantity. So this ruling kind of gave the MLB a right to have monopsony power in the labor market for Major League Baseball players. Right? We've seen this. There's another example, and I should probably know a little bit more about this one, the details. But some of the European soccer teams have deals with the government, like broadcast deals, well, broadcast TV broadcast deals. And so what that actually allows them to do is that the government kind of ensures that they're the only ones that the government is going to be the only kind of purchaser of these games. And so the government can get them at a lower cost, right? So that's another good example of some monopsony power, but kind of a weird one. Generally, for the sake of what we're doing, we'll talk about monopsony power in the context of the labor market. I think I talked about, here we go. Yeah, so this empty slide was kind of left for what I just drew there, so I jumped the gun a little bit, but kind of that's why I was leaving that there. So one thing I mentioned back here was the reserve clause also gave teams the right to kind of have monopsony power. So what did that look like? So the reserve clause was basically that once a contract was over, teams would retain the rights to make a deal with that player. So even, let's say I sign with the New York Yankees for 3 years. 3 years go by. I need to sign a new contract if I want to play with them again. What the reserve clause did was, even after that contract is over, the New York Yankees are the only ones who can make a deal with that player, right? They retain the rights to that player. So unless that player signs a deal with the New York Yankees or the New York Yankees trade them, those are the only two options, right? They can't just go out and sign another, sorry, this is past tense. They couldn't have went out and just signed another contract, right? So essentially this reserve clause was saying, like, I'm the only one who has rights to be able to hire your labor, or there's only one consumer of your labor, right? So this gave monopsony power. We have a couple cases, I think, I forget his first name, but Toulson was upset over going to the minors, right? He couldn't go to any other team because I forget the team that owned him at the time who sent him to the minors. Actually, I think this might be the Yankees. We'll see if I have something down here in a second. But he was upset and said, well, I can't sign with another team. I know that I'm good enough to play for any other team in the league, but I'm on the Yankees, And so they have this stacked lineup of really, really good players. And so I end up getting sent to the minor leagues. I should be able to go make a contract with one of these other professional teams and get paid like a professional player, right? So that was kind of his gripe. Curt Flood is then kind of the one that, there's some other cases throughout this time period, but kind of Toulson was a major one who tried to kind of get his case to be heard. But not until 1970, we get Cardinals outfielder Curt Flood. He was traded to Philly, and he didn't want to go. So why didn't he want to go? Because Philly was not known as being very accepting at the time, a lot of racial discrimination. And so he said, look, I was traded to the Phillies. I should have a right to sign a contract with another team if I don't want to. They just traded my rights. So it's not that they traded him along with his contract. They just traded the rights to sign that player, right? So he says, well, no, I don't want to be there. I don't have a current contract I'm being paid for. I should be able to go play for any team that is willing to sign me, right? So he filed a lawsuit, ended up losing, right? They said, no, that you don't have that right when you sign your contract. This is the reserve clause in the Major League Baseball. They own the rights kind of to you as a player, right? So, Curt Flood's not happy. A lot of baseball players at the time aren't happy. And so in comes Marvin Miller and says, well, look, the players are getting treated like trash, so we need a union, right? The only way to combat monopsony power is if we have a union, right? So he helps end the reserve clause. Eventually, from kind of pressure from the union, the league drops this reserve clause, and once your contract is up, you're free to go, make a deal with whatever team is willing to make a deal with you. Okay? So I think did I leave a slide here? I didn't, but there should be an empty slide here, so I'm going to draw something here real quick. So let's go to stop share. So just kind of I don't know what you guys did in your 201 courses if you didn't have me, which I don't think I have many people probably in here. So why does a union help kind of combat this monopsony power? I'm trying to get this straight here. We've got, let's think about quantity of labor and my wage, right? So I've got some demand for labor. I've got a supply curve for labor. Okay? Now, a perfectly competitive market is where supply is equal to demand, right? So we've got perfectly competitive, and then our perfectly competitive equilibrium wage up here. Okay? What happens if we have union power? Right? Well, essentially, it's kind of the exact opposite of a monopsonist, right? Because now, if all the players come together and they're operating only through the union, there's only one supplier of labor, right? Monopsonist was one consumer, right? The league that was trying to hire players, consume players, labor. Now we have one supplier. Well, what is one supplier? If we're looking at like a product market, if there's only one producer or one supplier, we have a monopolist, right? So basically, it allows the players to act as a monopolist in the labor market, which leads to fewer players, but those players who maintain their jobs, right, would choose the quantity based off where marginal revenue and the supply curve represents marginal costs, right? So marginal revenue is equal to marginal cost here. We choose that optimal quantity of labor to supply to the teams, and we can charge a higher wage per unit of talent. Okay? So unions can kind of combat that monopsonist power, right? And here we're thinking about, unions don't just battle for wages. I don't know if we'll get there today, but we have a lengthier discussion kind of upcoming about unions. But this is the general idea of how a union is going to work, right? They're going to do what? Well, with a union, wages should be higher, right? So those lower wages that were coming as a result of a monopolist, if we can get some monopoly power as a union, we can kind of combat those. Okay? Any questions on that before I keep moving? And I don't think we'll do it today. I might kind of revisit this next class But you can kind of imagine we could kind of overlay here a monopsonist in this market as well, where we have this like marginal expenditure curve, you know, and I could think about, well, where's the range of wages that they'll kind of be battling between. But we'll kind of save that discussion for later on in the semester. But that it is kind of something we could do, is see monopsonist and monopolist power in the same market. Okay. All right. Any questions at this point for me before we keep going? I want to make sure we kind of have an understanding of the union power, monopsonist power, and kind of thinking about this labor market. We okay with this? Yeah? Okay. So, then kind of making a little bit more relaxed conversation here, but we think about all the leagues and some of the monopoly power threats we've seen. Each one has kind of seen their own. So the NBA, you know, if we go back far enough, was competing with the ABA. Eventually those two merged, similar to the National American League. At some point when you're competing with another successful league, you realize if we merge together, we now have monopoly power. We're both going to be better off, right? NHL, same kind of idea. There was a World Hockey Association that they merged with in the late 70s. And the NFL is probably the one we've seen the most competition, which is, I already mentioned, I think, the AFL earlier. They merged back then with the AFL, but then we've had, you know, World Football League, Arena. I don't think I even have all of them on here, right? The Arena Football League, the Extreme Football League, which then made a comeback. What was it? A year or 2 years ago now? 1 year ago, right? Prior to COVID, right? So XFL. So there's been a lot of these competing leagues, right? And some of them have had different levels of success, but I don't think that there's probably any argument that any of them have gotten a product that, you know, is a perfect substitute with the games the NFL is providing. Right? If there was a league able to do that, based off of prior evidence that we've seen in the NBA, NHL, and MLB, we'd probably see a merger, right? If there were able to be a league that's producing a very similar or almost a perfect substitute and is successful. Okay. So along this idea of monopoly power, right? And I'll use the NCAA for this example because we see it play out a little bit more. And we're going to start diving into a little bit of game theory. So I'll do some refresher today on game theory so that we can understand some of the cartel behaviors of the NCAA. Right? So the NCAA is a group of teams, and they're coordinating their behaviors or their actions, right? So that everyone that belongs to the group will benefit. Right? It's essentially the definition of kind of a cartel. Right? We agree, you know, on a certain list of actions so that if we all adhere to these, we'll all benefit. Right? So we can set prices, we create various entries, whatever it may be, to kind of maintain more market power by being a monopolist or at least kind of moving away from that perfectly competitive market. So the NCAA is a little unlike kind of our traditional cartels. Usually we think about like oil companies kind of colluding on the price they're setting for oil. It's a little bit unlike that in some ways. They're not necessarily trying to maintain monopoly power, right? In fact, the NCAA does things that sometimes go against monopolizing a market by allowing more teams, right, so there's universities and schools that will, you know, start a basketball team, right? Well, if they were really concerned with keeping competition low, the NCAA wouldn't allow that, right? But really, it's more of a kind of central coordination for setting league rules, regulating student-athlete behaviors, the laundry list goes there. They're more focused on kind of the student-athletes, I don't want to know success, not in the sport, but like kind of protecting them, right? Another kind of odd thing about the NCAA is we're not really maximizing profits because, you know, a lot of these, if we look at, you know, what NCAA, even football teams are actually earning a profit, it's a much smaller amount than you'd think. And a lot of them, essentially, once they get profits, they just increase their costs and kind of win maximize, right? Because, you know, they're essentially like maximizing revenue, right? They're just trying to increase revenue as high as possible so they can just spend it, right? They're not trying to actually maximize profits. So it's a little bit different in that regard as well. Although if my expenditures are just on frivolous things, essentially what I'll do is try to maximize profits and then just spend the rest of the money on things that might not even help me increase my number of wins, right? So a little bit different than what we usually think about, but it's still, their behaviors allow us to understand some economic principles using game theory. So I'll set this up and then we'll do a review of game theory. So the NCAA limits the number of televised games, right? And especially if we kind of go back historically, they've limited the number of games, right? Because the more games you have on TV at the same time, the more competition you have, between, there's 50 games that the consumer can watch. So in 1984, the Supreme Court said this is a violation, right? You should be putting out, you shouldn't be constricting the number of your games that are televised. It's hurting consumers. There's a huge consumer surplus lost. And so we were saying this is, you can't do this, right? You can't limit the number of games. So a lot more deals were made. More and more games were televised, right? Well, this is going to be great for the consumer, but what's a problem with that, right? Well, if there's 50 games out there, right, the value of each game, right, kind of goes down. If there's only one game that's on TV at that time, well, these broadcast companies are going to be competing like crazy to be the ones that have the rights to show that game. But if there's 100 games that now we can pick which ones we want to televise, well, now there's not near as much competition for any one game. And so the value of that game, right, kind of decreases, or those those teams aren't able to kind of have any monopoly power so that they can, they're one provider of that game. They would have been able to charge a much higher price to these broadcast networks. So, more and more games are on TV, but what actually happens? Well, kind of the perfect example of this is one of the teams that had almost always was chosen as having a game on TV prior to this 84 ruling was Oklahoma. They were really successful. They typically were kind of always one of the better teams in the nation. And so they were actually one of the original teams who was kind of mad. When their game didn't get picked to go on national television, they got upset about it because they thought, well, we know that we can bring in a huge consumer base. We know that we can provide a high quality product, and we're losing money when we're not on TV and you put someone else on, right? So they were one of the original teams who brought this case to the Supreme Court. And what ended up happening is if you look at the year prior to the court ruling and post the court ruling, their revenues actually fall by 50%, right? And it's essentially because if you only have one game, you only supply one game, you have monopoly power in that market. As soon as you allow every game to be put on TV, right, you lose that power, and the price per game you can charge goes down dramatically. Okay? So they were kind of hurt by that, even though they were kind of the ones that originally pushed for it. Right? So I tried to explain this a little bit, kind of thinking about monopoly power, and maybe you were kind of envisioning what that drawing looked like, or what that graph looked like. But to better understand this, we can use game theory. Okay, so we'll kind of review it. I don't know if we'll get how many examples we'll get to today, but for sure I'll set us up so that we have a review of game theory. So a Nash equilibrium, right, is going to be a terminology that we typically use in game theory. And it's basically that each party, and typically we'll look at examples with only kind of two players or two parties, that they're both behaving in a way that is optimal to how the other person is behaving. I don't know if this is exactly how I said it here. It's probably more of a textbook definition here, but a Nash equilibrium is where we're both best responding to how the other person is behaving, right? Or the choices that they're making. Okay? So what I'm choosing to do is the best response to what you're choosing to do. And what you're choosing to do is the best response to what I'm choosing to do. Okay? So this was kind of, I always try to mention kind of, I probably should do a better job even in this class, but this is not really a sports movie, but it is a really interesting movie about John Nash, who was like this really, really genius economist who, I don't want to spoil the movie at all, but there's some bad things that happen in his life. But there's parts of this movie that lay out exactly how we should be thinking about Nash equilibriums very well, right? So the basics are, and for us, we'll just set it up as, we're going to have players and rules to this game. So typically we're going to look at models that have 2 players. We can have more than that, right? And when I say players, we're not thinking about baseball players. We're thinking about 2 people making decisions, or 2 companies making, 2 leagues making decisions. Okay? So usually we're going to look at models in this class with 2 players, and the rules are kind of referencing when decisions are made, right? Are we making decisions at the same time, or are you able to make your decision first and then I have to follow, right? That's kind of our rules portion of the players and rules. We then call the choices that people can make strategies, right? So each one of these players has different strategies they can choose, right? This could be as simple as I could go left or right if I'm walking forward, right? That's as simple, these strategies will be a little bit different depending on the example, but they're basically the possible actions I can make. Okay? We then have the payoffs, right? So once these strategies are chosen, right, the combination of the 2 players' strategies will produce payoffs for each one of those players, right? And I say payoffs here. I know we won't do one today. We might do it next class, where the payoffs actually could be costs, right? So it could be that we're trying to understand the costs that exist because of our behaviors. So it could be payoffs are positive or negative, okay? But generally, most examples are probably going to be some benefit to each team, or each player, I should say. So typically we use a normal form matrix, and this is kind of what I'll show you to represent the payoffs that exist from the different combinations of strategies of these 2 players, given the timing of the decisions. Okay. Is this looking somewhat familiar? Yes, kind of remembering some of this from 201. So here's the, here's the players. Let's say we have 2 firms, and they can either set a high price or a low price, right? Both of them can have those same decisions, right? It makes it a little bit easier. And then the payoffs are, if we both set a high price, right? Well, now, at least when a consumer goes to buy something, they're not, they don't know who to choose. It doesn't matter who they choose. If we're providing the same good and we charge the same price, well, that's okay. But, if we set the price too high, potentially we'll lose out on a lot of consumers being able to purchase this good. If we both set a low price, potentially that's not a great thing. If I set the price too low, I'm potentially losing out on some additional surplus I could be getting from consumers, right? If I could set the price a little bit higher. And then, if we have the different combination, if I set a low price and you set a high price, well, everybody's going to buy from me because we're providing the same product and I have the lower price. So that's really good for me. But if I set a high price and you set a low price, now no one's going to buy from me. They're all going to buy from you. So we're trying to kind of coordinate these decisions where it's always an incentive to be the person who sets the lower price, right? But if we both set a low price, we're both going to lose out on higher profits that we could have got from both charging the higher price. So how would you set this up with a normal form game? So typically how we'll do this, just draw a box and kind of break it into 4 squares. Okay? Now, there's 2 different ways of doing it. So when I go through the one example today, I'll show you a slightly different way that you can draw these normal form games. Either one's okay. A lot of times those, once you have those 4 boxes, you just split them into 2 and you write all of player 1's payoffs in the lower kind of triangles here and all of player 2's payoffs in the upper triangles. So here, this box, for instance, would represent if both firm 2 and firm 1 set high prices, here is what firm 1's payoff would be, and here is what firm 2's payoffs would be. Down here, this is if firm 2 sets a high price, firm 1 sets a low price, here's firm 1's payoff, here firms 2, and then so on and so forth. Right? So this is typically how we'll draw these normal form games. So game theory allows us to understand, using that matrix, what the best response is to each of the other players' possible responses or possible chosen strategies. Okay? So a dominant strategy is going to be when the strategy I choose is optimal no matter what the other player does. The other player can choose whatever strategy they want. If I have a dominant strategy, then this strategy is my best response no matter what the other person does. Right? And we can determine if we have one of those going on as we work through some examples. If both players have a dominant strategy, then we're going to have a Nash equilibrium exist for sure, right? In the sense that, if my best decision doesn't change no matter what you do, and your best decision doesn't change no matter what I do, well, then we know what decision both players are always going to make, right? Because it doesn't matter what each of them do, they're always going to make the same decision, right? So we call that a dominant strategy equilibrium. A prisoner's dilemma will exist when we end up at a Nash equilibrium that is actually a lower payoff than if both firms could agree on making other strategy choices, okay? So it results in payoffs for both of the players that are lower than if they could somehow come to an agreement to change their strategies. And we'll see, well, why don't they just agree? We'll see why here in a second. Okay? So prisoner's dilemma is when we end up with this kind of negative outcome for both players involved. Right? So let's set up this example. And I wonder if I can do this. Let me think if the best way to do this. It might be to switch over to writing it. Let's see how small this ends up being. So let's set this up. So IU and Purdue, I just chose those two schools, right? They're in the same state, and they're thinking of both about how many games they want to televise, right? They know that the more games that they televise makes each game worth a little less, right? Because now if I'm choosing which game to watch, there's more games to choose from. And so, and they're both thinking about kind of playing in similar time slots on the same day, right? I set this up so that you couldn't argue like, well, wait, what if one of them chooses to play at 8 at night and the other is playing early in the day? They're not really competing against each other. Assume they're looking at similar time slots and similar days, right? So if both teams televise their games at the same time in the same days, they'll both earn, all their games at the same time, the same day. They'll earn kind of $8 million for the entire season, right? Their payoffs will be the same here. If both teams can agree to only televising half their games, that way they can alternate, right? So that only one of them is playing on TV at one point in time, right? They'll split the number of possible TV appearances in half, right? So that the value stays high, right? There's no choice. Any day you want to watch a game, there's only one game now on. And so they can keep that monopoly power, and they'll both earn higher profits of $14 million, okay? Excuse me. If one team televises half their games, but the other televises all their games, well, now the team televising all their games gets $18 million, and the other team who only does half gets $4 million. Well, why is this the case? Well, if I'm the one who chooses to put all of my games on, half my games will have no competition, and the other half, before when we both agreed to only do half games, I was only getting, the monopoly profits from half the games. Now, the other half, I'm not getting zero. I'm just not getting monopoly profits. I'm splitting kind of the profits that would exist in that market for the other half this season. So if I'm the one who puts on all my games, I'm making more money than the team who stuck to our agreement and only put on half their games. So given these payoffs, we can start to build this normal form game. So I'm going to try to keep this on the screen. I wish I could make this a little bit bigger. Someone should tell Zoom to allow that. So let's set this up. Oh. Here we go. Come back. Let's go to the dot cam. I'm getting there. Slowly but surely. There we go. And I'll switch over this so we can see it a little bit more, larger. I just want to kind of, I think seeing the data and seeing me build it will help. So I've got IU and Purdue as my two players. Okay? And then I'm going to say they can do all their games or half their games. Right? I'll draw I didn't really draw that really well, but there we go, right? There's my kind of payoff matrix. Okay? So I just got here's my two players, and then their two choices. Right? So when they both put on all their games, right, they only earned $8 million. So I'll show you the other way of writing these normal. Instead of kind of drawing these like triangles, this is probably how I'll do it more often. I just think it's easier. You'll write firm one, or player one's payoff. I shouldn't say firm. Player one's payoff first. So here it was 8 million. And then a comma and write player two's payoff second, right? I think this is an easier way to look at it, but you'll see it kind of displayed in other places as what I originally showed you. We also had, if they both can agree to put on only half their games, they can both earn, is it 14 million? Yeah, 14 million, right? We then said, if one of the teams puts all their games on, but the other only puts on half their games, the team that puts all their games on gets a payoff of 18 million. Well, here, and the other only gets 4. Here, IU is player one. They only put on half their games, so here they would only get that 4 million, while Purdue putting on all their games would get the 18. And then up here, if Purdue only put on half their games, well, they're player two, so they only get 4 million. IU put on all their games, so they got the 18. Okay? So that was just kind of from the information we were given. So let's make this a little bit bigger, right? Any questions over any part of that process before we continue to move forward? Okay, we're kind of constructing these. I don't see anything in the chat, so we'll assume we're good. So now what I do, I'll walk you through the process of finding the Nash equilibrium. Right? So what I'll do is say, look, if I'm Purdue, right, I'm making decisions based off my payoffs. I don't care about IU. Right? I want to get the highest. If we think about these as profits or revenues, I'm trying to get the highest profit for me. So Purdue looks at this and says, okay, look, if IU puts on all their games, what would it be my best response to do? Well, if they put all their games on TV and I only televise half, I'm going to make $4 million because I'm losing out on the other half the season. If I instead put all my games on, I'll go from 4 to 8 million. Which is better? Not a trick question. 8 million is better than 4 million, right? So Purdue says, well, look, if IU puts all their games on, it's optimal for me to choose to put all my games on as well. Well, what about, getting creative here, what if IU puts on half their games? Well, now what is it optimal for Purdue to do? Well, they go down here, they look at their payoffs and say, oh, come on. Well, if I put half my games on, when IU puts half their games on, and we kind of, alternate, we agree to alternate, I get 14 million. But if I'm sneaky and I tell them, yeah, I'll alternate games with you, but then I put all my games on television, I'll get 18 million. So what's the best response to IU choosing half for Purdue? Well, 18 million is greater than 14 million. Right? And then we do the exact opposite thing. Now here, all the payoffs are kind of symmetric here, right? They mirror each other, so it's not as interesting, but this is still the process you would use. So now we think about, okay, what's IU's best decisions? Well, if Purdue puts all their games on TV, IU looks at these payoffs and says, it's better for me, 8 opposed to 4 million, to put all my games on as well. What about if Purdue chose to only put half their games on? Remember, IU's payoffs are here in the first slot, so they look at this and they say, well, if they only put half their games on TV, it's actually optimal for me to put all my games on TV. This is the way that I think is the easiest to solve these games. You go through and you circle the best responses to all the possible strategies of the other player, right? Once you do that, anytime you end up with two players that are best responding to each other's behaviors, right? Or two circles in the same box here, right? This is a point where they're both best responding to each other. This is your Nash equilibrium, right? For both of them to televise all their games. Now, even though this is Nash equilibrium, it's a prisoner's dilemma Nash equilibrium. Because why? We're actually worse off than if we could both agree to only put on half our games, right? On every other, every other day. So, we both made decisions that got us to this point. So why is that the case? Let's think about, I'm gonna get real creative and just There we go. Let's think about if we were down here, right? So we both agree to put on half of our games. Awesome, right? We're both going to get 14 million apiece instead of 8 million. But for both teams, they look at this and say, yeah, but if he sticks to the agreement, right, if Purdue only puts on half their games, and I, as IU, decide, well, I'm not going to put half my games on anymore. I'm going to put all my games on. I can increase my profits, right? So both teams kind of have that incentive to deviate away from this point that they would agree on, that they both be better off, right, than the resulting Nash equilibrium. Better off than the resulting Nash equilibrium. Okay. I said that a little slow. So, any questions on that? Thought I saw a hand up, but it might have been a stretch there. Nothing in the chat. Okay. So we've solved our kind of normal form game. Pretty easy. This is a good example of a prisoner's dilemma. Let me see. What else did I have here? Because I'm thinking about where I want to end. Yeah, let's work through this example too. Why not? I kind of like this one. It's kind of fun. So this is not a perfect example, but I thought it was a kind of a fun one to think about. It's not far from being a good example. Well, let's say you go back, and I forget the year now. It would have been like 2014 or 15 maybe. But the Seahawks were playing the Patriots. Right, they were on the 1 yard line, and I think a score would have put them up and potentially won the Super Bowl. And not scoring ends up you lose, right? So you have a decision at that point to either run or pass the ball. Okay? Patriots had a decision that they could load the box, kind of having a defense that was more similar, like more apt at handling the run, and then you could also kind of come up with a defensive strategy that would have been more apt. Oh, okay. Well, okay. But this is an interesting way to think about this, right? So you could choose a defense that's more apt at handling a running play or more apt at handling a passing play, right? So I kind of rounded a lot of these to make the numbers easier, but I tried to look up what the percent of plays would have gained a yard on the goal line. And obviously, every running play isn't the same, and every defensive scheme to go against the run isn't the same. So this is why I said it's not a perfect example. But let's say if Seattle runs the ball, right, chooses a play to run the ball, and New England decides that they're going to defend kind of the run or choose a defensive scheme that's more apt at defending the run, there's a 57.5% chance Seattle scores, right? Because, New England isn't maybe New England is good at defending the run, and potentially Seattle is not. Right? Their strong suit isn't running the ball, so it's about a 50-50 shot. However, if New England decides to defend the pass in that situation, well, Seattle's a good enough run team to where if you don't choose the right defensive scheme, there's a much higher likelihood they score, right? And then kind of the reverse, if Seattle decides to pass the ball and New England defends the pass, maybe they thought that, New England's secondary was really good, and if we end up deciding to pass the ball, if they guess right, there's a much, much lower 27% chance we're going to score. And even if they defend the run, right, the chance that we score with the passing play is 72.5%. So what would be the optimal decision here be? Okay. So we'll set this up. And let's see. Hopefully I can remember all those numbers. But we've got Seattle up here, right? And then kind of New England. Those are our two players, right? Seattle can run, kind of choose a running offensive play or a passing offensive play. And then New England can decide to defend the run or choose a defensive scheme that is more apt at defending the run or choose one that is more apt at defending the pass. Right? So when Seattle ran the ball and New England chose a defensive kind of play that went up well up against that, I think what I had there, if I remember right, was that there was a 57.5% chance that New England scores. New England. That Seattle scores. So I could actually think about the payoff here, right? If if I just think about the percent, the payoff, like I either score or I don't. So I can almost think about that as a 1 or a 0, right? Scoring as a 1. So the expected value of these two strategies being played, there's a 57.7% chance that Seattle scores, which would mean that, what? 42.5% chance that New England stops them. Excuse me. So you can think about these percent chances as payoffs, because if I stop them, that's a good thing for me. I win the game. I get a 1, right? 1 times whatever the percent, or you think about these as probabilities for 1 and 2. And then for Seattle, the good thing is that if I score, I win the game. So there's a 57.5% chance I score. I think I said if they defend the pass and Seattle chooses to pass the ball, that for Seattle, there was only a 27% chance they stopped them, which means, 27% chance that they scored, which means there was a 73% chance that New England would stop them from scoring. And then if Seattle ran the ball, but New England defended the pass, we said there was an 80% chance Seattle scores, which means there's a 20% chance that New England stopped them. And then if they decide to pass, but New England just chooses to defend the run, this is going to be, of course, the one that I can't remember. 72.5. Okay, so there's a 72.5% chance if New England guessed wrong here, right? Defended the run when they were actually in the pass. So that would make what? 27.5% chance that they actually stop them. So we've got all the payoffs now set up. Now it's just a matter of identifying that Nash equilibrium. If, right, New England decides to defend, kind of comes up with a play that is better at defending the pass, what should Seattle do? Should they pass the ball or run it, right? Well, you should definitely go with the 80% chance of scoring over the 23% chance, right? What if New England decides to defend the run? We look here. Well, now the optimal decision is actually to go the other way, right? If they're going to defend the run, it's more optimal for me to pass. You can kind of imagine how this probably plays out, because no matter what the other person does, it's always optimal for me to choose to do the, well, for the offense, it's optimal for them to choose the opposite of what the defense is doing, right? For the defense, it's optimal to choose whatever the offense is doing, right? To make the right decision to defend it. So if Seattle decides to run the ball for player 1, what should they do? Well, they want the highest percent chance of stopping here. They should choose, if they're going to run the ball, I should defend the run, right? It's a much higher percent chance I can stop them. If they decide to pass the ball, well, I should decide to defend the pass. There's a much higher percent likelihood that I actually stop them there, right? Well, this is a weird scenario, right? Not Nash we don't have a Nash equilibrium here. We don't have a prisoner's dilemma because we don't even have a Nash equilibrium, right? We look down here and say, none of these kind of optimal decisions are the best response to each other. And that kind of makes sense, because if the offensive team decides to run it, as a defensive team, I should be defending the run. But if I'm defending the run, the offense's optimal decision is to pass the ball, right? But then if they pass the ball, the optimal decision for me is to defend the pass. But if I defend the pass, the optimal decision is for them to run the ball. This is we kind of keep going, right? And so we don't end up with any Nash equilibrium here. Now, if the numbers were a little bit different, potentially we could, right? If there was, maybe a team that was so dominant at the run that even when the defense defended the run, that payoff was higher. So for instance, if here, let's say we thought Marshawn Lynch was amazing, right? Like, I don't remember who is it? Jen is saying over here, right? So let's say, I don't know, we think that this is like a 75% chance here, right? Which would lower this to 25. Well, it's still optimal for New England to choose this, but now 75 is higher than 72.5. We would actually end up with a Nash equilibrium where I'm going to run the ball and you're going to defend the run, right? I'm just so dominant that I don't care. I'm not trying to choose something that is going to go up better against your defense in the sense of I'm not going to try to pass the ball when you're defending the run. My run game's so good, my pass game is so bad that I should still choose to run the ball, right? But like I said, I tried to pull some of these numbers from the actual season. So you can kind of play around with toy examples like this. It's kind kind of interesting to think about what you do. A lot of times you'll see they set these up for these examples up for penalty kicks, right? Should the goalie guess left or right, and should the shooter try to kind of go left or right? And it depends on how good are they at shooting goals when they're going to the left side of the net versus the right side of the net. How good is the goalie going to his right or to his left, or her right or left, depending on maybe what hand they are or what their skill set kind of is. So we can set a lot of different things up like this. This is just kind of an intro to game theory. We'll push it a little bit further as the course goes on. But yeah. So that homework, I'll extend it to the end of the day today, and you can upload it anytime tonight. If you've already uploaded it and want to work a little bit more on one and then re-upload it, I'll just look at kind of your most recent submission. Okay? Other than that, any questions for me before we get out of here?
Yeah, are you able to hear me?
Yep.
Okay, so I had to help my roommate get his car unstuck earlier, so I had my other roommate take a picture of a graph you drew. It had the supply and demand, and then it had another curve that was labeled ME. What was ME? What did that stand for?
ME. So if we're going back and looking at the monopsony, it was marginal expenditure.
Okay, so they would just hire until it crossed marginal benefit, basically?
Yep.
Okay, thank you.
All right, any other questions? Otherwise, we're getting out of here.